First of all, I welcome all of you in Life is Learn YouTube channel, and today we will discuss about a galvanic cell. And in this video we will discuss about galvanic cell representation with the help of diagram, and how to represent galvanic cell in short form we will discuss in this video. And in this video we will discuss about each and every term related to galvanic cell also. Okay, now let's start with galvanic shell. We will see the definition of galvanic shell. Galvanic shell is an electrochemical cell that uses the transfer of electrons in redox reactions to supply an electric circuit. This cell is driven by a spontaneous chemical reaction that provides an electric current through an outside circuit. Galvanic cell reactions supply energy which is used to perform work. Okay. For this reason, galvanic cells are commonly used in batteries also, no? In cell phone there is battery, and battery is made up of galvanic cells. So in our daily life we are using galvanic cells which is made up of solutions, that is two solutions, and these solutions creates the electrical charges, no? From this video we will understand about these things. Okay, this is galvanic cells. About the definition, we are seeing the definitions of galvanic cells. And in galvanic cells the term related, that is electrode. What do you mean by electrode? An element, that is zinc rod or copper rod, dipped or contact with its own ion solution, that is ZnSO4 and CuSO4. That whole arrangement is known as electrode. Okay, or we can say zinc electrode and copper electrode. From the diagram we can understand brief, that is what do you mean by zinc electrode and copper electrode. Okay, this is the diagram. At anode there is negative sign, and zinc rod is there. Zinc rod is dipped in its own ion solution, that is ZnSO4. This solution is 1 molar solution, and this whole arrangement is known as zinc electrode. Okay, this is container, and in container there is ZnSO4 solution. Okay, and there is zinc rod is dipped. Okay, this is very simple diagram. We can understand from this diagram about the electrode. Okay, so this is the diagram at anode, and at anode there is oxidation, and the reaction of oxidation, that is Zn solid plus Zn2 plus aqueous plus 2e minus. Okay, and in the case of copper electrode we can see from the diagram, this is the cathode, and at cathode there is positive charge, and copper rod is dipped into its own ion solution, that is CuSO4 solution. This is 1 molar solution. Okay, and there is a reduction. For the reduction, this is the equation: Cu2 plus aqueous plus 2e minus is equal to Cu solid. Okay, and now the terms related to galvanic cells. There is switch in galvanic cell. Why we are using switch in galvanic cell? Because to operate galvanic cell, okay, we are using switches. Without using switch there is no any flow of electrons, there is no transfer of current, no. So we are using switches. Okay, and this is voltmeter. We are using voltmeter to determine the flow of current. Okay, charges, and current, direction of current is from cathode to anode, and direction of electron, that is from anode to cathode. Okay, and current direction is just opposite to the direction of electron. Why? By sign convention, direction of current is opposite to that of electrons. Okay, and now whole arrangement is connected with the copper wire. We all know switches, voltmeter, anode and cathode all are joined with the wire. Okay, and now salt bridge. About salt bridge we will discuss. Salt bridge. This salt bridge is made up of KCl and agar-agar. Why we are using salt bridge in galvanic cell? To neutralize the solution, we are using salt bridge. Okay, migration of ions from salt bridges. Okay, KCl is used as a salt bridge because it produces positive K plus ions and negative Cl minus ions as the salt bridge needs to transfer the neutrality in the system. Okay, for the neutrality we are using galvanics in the galvanic shell, the salt bridges. Okay, and this is the reaction at anode and this is reaction at cathode. We will just mix these two equations and form the another equation for the reaction. Okay, cell reaction for zinc and copper electrode. Reaction at anode. Okay, Zn solid is equal to Zn2 plus aqueous plus 2e minus, that is oxidation half, and reaction at cathode, that is Cu2 plus aqueous plus 2e minus is equal to Cu solid, that is reduction half, and LHS we have to put in LHS part and we have to put RHS part. Okay, then after we will get the final equation, that is Zn solid plus Cu2 plus aqueous is equal to Zn2 plus aqueous plus Cu solid. Okay, this is the reaction for the zinc and copper electrode. Okay, and now we have to represent, if we have to represent galvanic cell in very short word. Okay, we are not representing galvanic cell with the help of these diagrams. Okay, these diagrams, but the question will be, we have to represent galvanic cell in very short form, then we have to apply this very short form, that is this reaction. Zn solid, one vertical line, Zn2 plus 1 molar solution, two vertical line, and Cu2 plus 1 molar solution, one vertical line Cu solid. Okay, one vertical line shows electrode, symbol of electrodes, and two vertical lines shows salt bridges. Okay, this is the Zn solid, one vertical line, Zn2 plus 1 molar solution shows the reaction at anode from there. Okay, from this reaction these are put here, and this represents at zinc electrode. This symbol, this part shows the symbol of anode part, that is zinc electrode. Okay, and this part, that is Cu2 plus 1 molar solution, one vertical line Cu solid shows copper electrode. Okay, and two vertical line, that is salt bridges. So we have to uh, represent galvanic cell in very shortly, then we are using this reaction. Okay, and now we are familiar about this galvanic cell. In this video we understand many terms related to galvanic cells. Okay, and this is the diagram, we all know about this diagram. Okay, thank you. I hope you will understand this video and each and every term related to galvanic cell. Thank you for watching this video, and if you want to subscribe this channel, you are free to subscribe it, and we are creating many videos to help the students. Okay, so if any problems faced by students, they are just solves problems from this video, and please subscribe the Life is Learned channel. Okay, thank you for watching.